This is our video lesson for 10.4 inscribed angles. So we're going to go ahead and start with a circle with an inscribed angle. And inscribed means that is drawn inside. So in means inside, and scribed is another way to say right, and then it's an inscribed or an angle drawn inside. So the angle drawn inside is in pink, and where the two rays end, we call that the intercepted arc. I apologize, I mean to say line segment. So most of today's lesson is going to be on the inscribed angle theorem that states the inscribed angle is 1/2 the intercepted arc. That means that the intercepted arc is double the size of the inscribed angle. So in example 1, we are given a circle with an inscribed angle of 51 degrees, and it asks us what is the measure of arc BC. Using what we know from the inscribed angle theorem, we know that the angle BAC is times 2 is going to be the measure of arc length BC. We can go ahead and plug in 51 for our angle and then multiply it by 2, and we get 102, and we can plug that into our circle. In example 2, we have a quadrilateral that is inscribed inside of a circle. I know it looks kind of like an oval, I apologize, but we know that we are given the 80 degrees, and that we're looking for the measure of QRT, which we can see in the blue pen on the left side. So using what we are given, the measure of QRT, again using the inscribed angle theorem, we are able to find the measure from QST by multiplying by 2. So let's go ahead and plug in 80, and now we multiply by 2 to get 160. So now we know that from Q to T, on the right side is 160 degrees, and we are now looking from QRT, which is the other half of the circle, and we know that a full rotation around the circle is 360 degrees, so if we add those two together, we should get 360 degrees. So let's go ahead and plug in what we have. So we can put in 160 for QST, subtract it on both sides to isolate the QRT, and we get that the measure of QRT is 200. And for our final example, we are given another quadrilateral, and we're looking for the measure from J to L. We are given the distance from K to L is 48 degrees, but we need the whole thing. We know that because this is an inscribed angle and it intercepts the arc LJ, we just need to multiply it by 2 to find that distance. So let's go ahead and multiply 50 by 2, and we multiply by 2, we get 100. So we know that the distance from L to J is 100. And if we wanted to find the distance from K to J, all we have to do is 100 minus 48, and that gives us 52 degrees. Now, if we want to find the distance from J to M, again, we know that the whole thing should add up to 360, so if we take out all the outside and subtract it from 360, that'll give us JM. And then that means we get 360 minus 120 minus 48 minus 52, or 140 degrees. And that's it for this video.